There is a piece of linen approximately 4.5 meters long, sitting in a climate-controlled vault beneath the Cathedral of St. John the Baptist in Turin, Italy. It has been there, in various forms of storage and protection, for centuries. Popes have knelt before it. Scientists have argued over it. Historians have attempted to trace its origins across continents and millennia. Millions of people have traveled significant distances simply to be in the same room with it. And after more than 100 years of increasingly sophisticated scientific investigation, the central question remains exactly where it started. What is it? Not what does it mean to believers, not what does it represent to the Church. Those conversations have their place. This is a different conversation. This is about what happens when you apply forensic genetics, high-energy physics, botanical analysis, spectroscopy, and X-ray crystallography to a single piece of ancient cloth, and the results refuse to align with any simple explanation. Because here is what actually happened when science entered this investigation with the intention of resolving it. The data did not resolve anything. It deepened the problem. It produced findings that neither confirmed the medieval forgery theory nor established clear proof of anything supernatural. It produced findings that no one had predicted and that no existing framework fully accounts for. That is not a mystical claim. That is a description of where the research currently stands. Let's go through it carefully, layer by layer, beginning with the moment that changed everything, not a laboratory result, but a photograph taken in 1898 by a man who nearly dropped what he was holding when he saw what was developing in his darkroom. The negative that started everything. On May 28, 1898, a lawyer and amateur photographer named Secondo Pia was granted permission to photograph the shroud during a public exhibition in Turin. He set up a large format camera on scaffolding inside the cathedral, used magnesium flash lamps to illuminate the dim interior, and exposed 2 glass plates measuring 50 by 60 centimeters each. That night, developing his plates in a home darkroom, Pia lowered one of the plates into the developing bath and waited. What emerged stopped him cold in a standard photographic negative. Light areas of the subject become dark on the plate and dark areas become light. The tones are reversed. When you photograph a painting or a stain on cloth, the negative version looks distorted, unnatural, flat, difficult to read. Pia's negative did the opposite. The faint, indistinct image visible on the shroud itself, something that had always looked like a vague, difficult-to-read stain, became, when reversed photographically, a sharp, high-contrast, anatomically coherent portrait of a human face, deep-set eyes, a prominent nose, a forked beard bruising along the right cheekbone. An expression that combined dignity with evidence of significant physical trauma. The image on the cloth was already a negative. Pia's photograph had simply reversed it back to positive. Here is the question that has never been satisfactorily answered. Who in medieval Europe, or at any point before the invention of photography in the 19th century, understood the principles of photographic negation well enough to deliberately construct an image that would only reveal its true detail when reversed by a process that would not exist for another several hundred years? The human visual system does not perceive the world in negative. The brain cannot naturally compose an image in inverted tones, and there was no mechanism available to any medieval artist to preview, verify, or correct such a composition. This is not a theological argument. It is a perceptual and technical observation. The shroud does not behave like any other painted or drawn object from any era of art history. That single fact has driven over a century of scientific investigation, and the investigation has not made things simpler. Before we continue, what is your instinct at this point? Does this seem like evidence of something genuinely unexplained, or do you already have a theory? Keep it in mind as we go through the rest of the findings. We will come back to it. The DNA investigation and what it revealed. In 2015, a genetics team led by Professor Gianni Barcaccia at the University of Padua was granted access to the shroud for a DNA analysis project with a specific and carefully defined scope. They were not attempting to identify Jesus Christ. There is no reference sample for that comparison, and the researchers were explicit about this from the outset. Their goal was more measurable: to reconstruct the travel history of the cloth by identifying whose biological material had accumulated on it over time. The methodology was rigorous. Sterile micro-vacuum devices equipped with ultrafine filters collected dust, pollen, and organic particles from the fabric surface and from deep within the spaces between individual threads, locations where ancient material can remain sealed for extended periods. Additional samples came from particles collected during earlier restoration work and preserved in archival storage. The samples were transported to an ultra-clean laboratory environment. Analysis used next-generation sequencing technology, focusing on mitochondrial DNA, a form of genetic material that exists in higher copy numbers per cell than nuclear DNA, survives longer in ancient material, and passes exclusively through the maternal line, making it a reliable marker of geographic ancestry. Computers ran the sequencing data for weeks, comparing millions of nucleotide sequences against global genomic databases covering populations from across the world. The results were published in the journal Scientific Reports. The reaction in the scientific community was, by the standards of academic literature, extraordinary. What the researchers had expected to find was a dominant signature corresponding to one geographic region. If the shroud were a medieval French forgery, European genetic markers should have dominated. If it were an authentic first-century relic that had remained in the Middle East for centuries, Middle Eastern signatures should have dominated. What they found was neither. The genetic data revealed identifiable markers from the Middle East, specifically haplogroups associated with the Druze, a historically isolated ethno-religious community from the mountainous regions of Israel, Lebanon, Jordan, and Syria, whose genetic profile has remained remarkably stable over thousands of years due to centuries of limited intermarriage with outside populations. The presence of Druze-associated DNA is considered a strong indicator of geographic origin in that specific region of the ancient Levant, beyond the Middle Eastern signatures. The data showed markers associated with Western Europe expected, given the shroud's documented presence in France and Italy since the 14th century. It also showed haplogroups linked to North and East Africa, to the Indian subcontinent, and to East Asia. Let that last point register. Genetic signatures traceable to China and India appeared on a piece of cloth that many argue never left a French monastery until the 15th century. How is that possible? The relic as a traveler. The genetic distribution did not look random. When mapped geographically, it aligned with a specific historical route that researchers had largely treated as legend. The documented journey of a relic known as the Mandylion, a facial image venerated in the early Christian world across the ancient trade networks of the first millennium, according to Byzantine, Syrian, and Arabic historical sources. The shroud, folded so that only the face was visible and displayed within a protective casing, traveled from Jerusalem to the city of Edessa in the 2nd century, where it reportedly remained for several hundred years before being rediscovered. Edessa sat at a key intersection of the ancient Silk Road. Merchants, pilgrims, and diplomats from China, India, Persia, and Arabia passed through the city regularly. Each of them in proximity to the relic would have deposited microscopic biological traces, skin cells, hair fragments, perspiration onto the cloth's surface. From Edessa, historical accounts place the relic in Constantinople from 944 until 1204, when the city was sacked during the Fourth Crusade and the shroud disappeared from documented record. Later accounts place it in Athens briefly before it reappeared in France in 1353, in the possession of a French knight named Geoffroy de Charny. The genetic data on the shroud does not contradict this route. It maps onto it with a precision that researchers found difficult to dismiss. A medieval forger working in 14th century France could not have gathered biological material from populations in China and India. Those populations were known to European scholars primarily through traveler accounts. Physical contact that would leave identifiable genetic traces was simply not a feature of medieval European daily life. The DNA found on the shroud is not random contamination. It appears to be the accumulated biological record of every community that came into sustained contact with the cloth across a journey spanning more than 1,000 years. Whether that journey began in Jerusalem in the 1st century or somewhere else at a later date is what the remaining evidence attempts to address. Pollen, the invisible geographic fingerprint, working independently. Israeli botanist Avinoam Danon of the Hebrew University of Jerusalem and Swiss forensic scientist Max Frey, a pioneer of forensic pollen analysis, examined microscopic plant material trapped within the linen's fibers using adhesive tape samples. They identified pollen from 58 distinct plant species. 17 of those species are native to Europe, consistent with the shroud's documented history over the past 6 centuries. The majority, however, came from elsewhere plants native to the Middle East, Turkey, and the Anatolian Plateau, precisely matching the geographic route described by the historical accounts. Among the findings was a concentration of pollen that became a focal point of botanical research. Gundelia tourniforta, a thorny desert shrub native to the region between Jerusalem and Jericho. Its pollen accounted for nearly half of all plant material recovered from the cloth. Why would a thorny thistle plant dominate the pollen profile of a burial cloth? The concentration was highest around the areas of the cloth corresponding to the head and shoulders of the figure. Gundelia tournifortia has long, rigid, needle-like thorns. It blooms in early spring in the Jerusalem region. During the period of Passover, its physical characteristics make it consistent with historical descriptions of the crown of thorns. A second plant, Zygophyllum dumosum, is endemic to a narrow geographic corridor covering the Judean desert and parts of the Sinai Peninsula. It grows nowhere else on Earth. Its pollen was found on the fabric in significant quantities. No forger working in France could have applied pollen from plants that grow only in Israel at a microscopic level. Paint leaves brushstroke evidence. Pollen does not behave like paint. It settles, it embeds, and it stays where it lands. It functions as a geographic seal, one that cannot be deliberately placed without physically transporting the cloth through the specific environments where those plants grow. The blood and what it contains. For many years, critics of the shroud's authenticity argued that the reddish marks visible on the cloth were pigments ochre, cinnabar, or tempera applied by an artist with a detailed knowledge of crucifixion wounds. That argument became significantly harder to maintain after 2017. A research team led by Professor Giulio Fanti at the University of Padua, working with physicians from a hospital in Trieste, examined the stains using transmission electron microscopy and Raman spectroscopy, techniques capable of analyzing material at the nanoscale level. What they found was not pigment. It was human blood, classified as type AB. AB is among the rarer blood types. Its presence is notable but not remarkable on its own. What was remarkable was what the blood contained. Within the samples, scientists identified nanoparticles of creatinine and ferritin bound to hemoglobin in concentrations that have a very specific clinical meaning. Such concentrations appear in human blood under one condition: severe, sustained physical trauma. Specifically, the kind of trauma that destroys large amounts of muscle tissue, a process called rhabdomyolysis, flooding the bloodstream with creatinine as the muscles break down. The biochemical profile of the blood on the shroud is consistent with a person who had been subjected to extreme, prolonged physical violence before death. The chemistry encodes the physiological state of the individual at the time the blood was deposited. No artist can paint a biochemical signature. An artist can replicate the visual appearance of a wound, but cannot reproduce the molecular composition of traumatized blood. The distinction is absolute. Additionally, the blood on the shroud retains an unusual reddish coloration rather than the dark brown or black that aged blood normally displays. Analysis revealed elevated levels of bilirubin, a compound released by the liver under conditions of extreme physical stress. Bilirubin preserves the red pigmentation of hemoglobin for extended periods. The blood of a severely traumatized individual would display exactly this characteristic. This is not a mystical finding. It is a documented biochemical consequence of extreme physical suffering. The shroud's blood chemistry is consistent with it. The radiocarbon problem. In 1988, 3 independent laboratories, Oxford, Zurich, and Arizona, conducted radiocarbon dating on a sample taken from the shroud. Their results were consistent and were reported with high statistical confidence. The fabric dated to between 1260 and 1390, the Middle Ages. The conclusion appeared definitive. The scientific community largely accepted it. Even the Catholic Church stepped back from classifying the shroud as a relic rather than an icon. But science revisits its conclusions when new evidence emerges. And in this case it emerged. The problem was not the radiocarbon dating methodology. The problem was where the sample was taken from. The 1988 sample came from a corner of the cloth, one of the most frequently handled sections over centuries of public display. It was also, as subsequent chemical analysis revealed, a section that had been expertly repaired at some point during the medieval period. The repair involved weaving cotton threads into the existing linen structure, dyed to match the aged color of the original fabric, and treated with binding agents to make the repair invisible to casual inspection. Chemist Raymond Rogers of Los Alamos National Laboratory confirmed the presence of cotton fibers in samples from the tested section, along with dye residues consistent with a repair rather than original fabric. The main body of the shroud contains no cotton, it is linen throughout. The radiocarbon laboratories had dated the patch, not the shroud. This is not a minor methodological quibble. Selecting the most contaminated, most frequently handled, and most recently repaired section of an artifact for dating analysis represents a fundamental sampling error. The analogy is straightforward. Attempting to determine the age of an ancient artifact by dating the material added to it during restoration does not produce a date for the original object. The 1988 results remain valid for what they measured. What they measured was not representative of the shroud as a whole. The X-ray clock in 2022. Italian physicist Liberato De Caro at the Institute of Crystallography in Bari applied a dating method that bypasses the contamination problems inherent in radiocarbon analysis. The technique is called wide-angle X-ray scattering, or WAX. Rather than measuring radioactive carbon decay in organic material, it analyzes the aging of the linen's cellulose structure at the atomic level. Over time, the long polymer chains that give linen its strength naturally break down. The crystalline structure of the cellulose degrades in a measurable, predictable pattern under exposure to background radiation, humidity, and temperature variation. This degradation process functions as an internal clock, one that cannot be affected by surface contamination, handling, or repair work. De Caro compared shroud samples with linen fabrics of firmly established ages, ranging from ancient Egyptian textiles dated to 3000 BC through medieval examples from the 10th to 14th centuries. The shroud's cellulose aging curve did not align with medieval fabrics. It was measurably older. The closest match was linen fragments recovered from the archaeological site of Masada in Israel textiles, dated to between 50 and 74 AD, the 1st century of the Common Era, the period of Roman-occupied Judea, a dating method that cannot be contaminated by surface material, applied independently of the 1988 methodology. Placed the fabric's origin more than 1,000 years earlier than the radiocarbon results suggested. That does not resolve the question. It deepens it, and it means the question cannot be considered closed. The image that physics cannot reproduce. The image on the shroud is unlike any other image produced by human hands in the entire documented history of art. There are no brushstrokes. There is no pigment. There is no ink. The image is formed by a chemical transformation of the outermost fibers of the linen, a process of oxidation and dehydration that extends to a depth of approximately 200 nanometers. For scale, a single human hair is roughly 70,000 nanometers in diameter. The image exists in a layer that is hundreds of times thinner than that. Attempts to replicate the image using acid, heat, and various radiation sources have produced partial results at best. The only technique that comes close to reproducing the specific optical and chemical characteristics of the shroud image is a brief, intense pulse of vacuum ultraviolet radiation. The operative word is brief. To produce the image across the full surface area of the cloth, the energy pulse would need to have lasted less than a billionth of a second. No technology available in any historical period before the present day could produce such a pulse, and even with current technology, replicating the full shroud image across 4 square meters using this method has not been accomplished. In 1976, researchers using image analysis software developed by NASA for space photography discovered something that had not been recognized before. The intensity of the image varies in a way that encodes 3-dimensional information. The darker areas of the image correspond to points where the body was closer to the cloth. Lighter areas correspond to greater distance, when this data is processed through 3-dimensional rendering software. The result is an anatomically accurate 3-dimensional representation of a human figure. Standard photographs do not contain this kind of spatial encoding. Paintings do not contain it. The shroud does. What do you make of that? Not in terms of faith, in terms of physics. What process produces an image with 3-dimensional spatial data encoded in its intensity gradients? The forensic anatomy. The physical details of the wounds recorded on the shroud have been analyzed by forensic pathologists, anatomists, and trauma specialists. Several of their findings deviate from conventional artistic representations of the crucifixion in ways that align with what forensic science now understands about the practice. The nail wounds on the shroud are located in the wrists, not the palms. Medieval and Renaissance art overwhelmingly depicts nail wounds through the palms. Modern forensic analysis of crucifixion has established that palm tissue cannot support the weight of a human body the nails would tear through. Wrist placement is anatomically necessary for the crucifixion position to function as an execution method. An artist working from artistic tradition would have depicted the palms. The shroud shows the wrists. Additionally, when nails penetrate the wrist at the specific location shown on the shroud, they impact the median nerve. Stimulation of the median nerve causes the thumb to contract involuntarily toward the palm. The hands on the shroud show no visible thumbs. They appear to have been pulled inward. This is a predictable consequence of median nerve damage that would not be known to a medieval artist and is not depicted in any historical artwork of the crucifixion. Analysis of the scourge marks distributed across the body, more than 100 separate wound patterns, shows a geometry consistent with the Roman flagrum. A whip fitted with weighted metal tips that produce a specific tear pattern in skin and underlying tissue. The distribution and angle of the marks are consistent with 2 individuals striking from different sides. Layer by layer, the forensic record encoded in the cloth aligns with what modern pathology understands about the mechanics of Roman execution. Science came to the Shroud of Turin expecting to settle a debate. It has been engaged with the problem for over a century, and the debate is not settled. What science has established is this: the cloth is genuinely ancient by at least one credible dating methodology. The DNA on its surface reflects contact with populations spread across the ancient world in a pattern consistent with a specific historical journey. The pollen it carries comes from plants that grow only in a narrow geographic region around Jerusalem. Deposited during early spring, the blood it contains holds biochemical markers consistent with extreme physical trauma. The image on its surface was formed by a process that no existing explanation fully accounts for, and the anatomical details of the wounds recorded on the cloth align with forensic knowledge that did not exist when any proposed date of forgery would have occurred. None of this proves a miracle. Science cannot prove miracles. That is not what scientific methodology is designed to do. What it can do is identify the boundaries of what is explainable and be honest about where those boundaries are. On the Shroud of Turin, those boundaries have not enclosed a complete explanation. After more than a century of investigation using increasingly powerful tools, the object remains in the precise language of science anomalous. That is not a word scientists use casually. Here is the question we want to leave you with, and we genuinely want your answer in the comments. Does the inability of science to fully explain something make it more likely to be miraculous? Or simply more likely to be something we do not yet understand? Is there a difference? Share your thinking. This is exactly the kind of question where your perspective matters not because there is a correct answer, but because the conversation itself is worth having. What you believe and why you believe it shapes the quality of the discussion this community builds together. If there is another historical mystery you think deserves this kind of systematic, evidence-first examination, name it below. The best suggestions will drive what comes next.